that life exists beyond planet Earth. However, it seems highly likely that it will have developed elsewhere in the universe, given the variety of life on our own planet and the abundance in the cosmos of the necessary elements. It's perhaps even possible that alien life exists, or at least once existed, in our very own solar system. It's thought that both Venus and Mars were hospitable once upon a time, for example, millions of years before they assumed their current conditions. Saturn's moon Titan, however, remains promising even today, especially from a distance. It has several features that are remarkably familiar to us, including liquid lakes and a nitrogen-rich atmosphere. It's also the same size as a planet, even though it is only a moon, being as it is larger than Mercury. However, for everything on Titan that apparently resembles Earth, there's a bizarre twist that goes to show just how alien this place still is. In 2022, scientists from Stanford University made a statement about how similar Titan and Earth look, but they truly meant it in a literal and superficial way. Yes, Titan looks like Earth, but it doesn't much behave like Earth. And its Earth-like features are often made of far weirder materials than you'd expect. For a start, those massive liquid lakes, they're not made of water. They're primarily made of liquid methane and ethane, which you definitely can't drink. If you stood on Titan's surface, these lakes would have a yellowish tinge thanks to the makeup of the moon's skies. Then there's the sky on Titan. It's filled with clouds that rain like ours do, only again, it's methane. There may be active cryovolcanoes out there too, blasting out frozen molecules as opposed to molten rock. And it's all extremely cold out there, with the haze in the atmosphere reflecting away sunlight, meaning the surface of Titan receives 99% less sunlight than Earth's, which puts its average temperature at roughly minus 296 degrees Fahrenheit. Titan does, however, have certain sedimentary rocks that are very similar to Earth's, called ooids. These spheroidal grains are made of calcium, and they form rock features known as oolites. While this may sound mundane, it tells us a lot about how Titan has a sedimentary system, much like on Earth, involving erosion, drift, and the formation of dense rocks as sediment gets dispersed by wind. It's one natural system that aligns it with us. Similarly, Titan's methane lakes likely suffer from coastal erosion, just like Earth's shorelines do, thanks to the storms that are there and the liquid transport cycle, which is much like the water cycle, only with all that liquid being methane instead of H2O. So we can broadly say that Titan looks like Earth because it has many of the same active systems as Earth does, even if they're driven by different things. Titan's methane lakes aren't completely alien either. Earth also has these too, in a way. We don't have lakes made of pure liquid methane because Earth isn't cold enough for methane to change from a gas into a liquid. But we do have lakes with lots of methane inside of them, thanks to decomposing bodies at the bottom. Not masses of human bodies, thankfully, but just the circle of life taking its toll on the many creatures that live in these particular lakes. The methane released by their decomposition is then sometimes frozen in spectacular and very distinct bubbles, visible prominently in Lake Abraham in Canada, for example. These bubbles, beautiful as they are then quite dangerous, because with the global warming process threatening to dramatically change the status quo, this previously untapped methane could soon be released back into the atmosphere as gas. This is something that Earth and Titan don't have in common. Titan is going to remain frosty forever, and it's probably better off that way. So if Titan, despite looking quite like Earth, is actually so cold and abundant in liquids we can't drink, why are scientists still so interested in it? Well, when it comes to exploration and potential habitability, it's for one thing better to have a planet that's too cold than somewhere that's too hot. Extreme heat is why we'll likely never be able to send humans to the surface of Venus, and why all Venusian probes have failed very quickly thus far. The Venera 12 probe arrived on Venus in 1978 and lasted for a record-breaking 110 minutes before failing. And that's still the longest-lasting one we've ever built. On cold planets, however, like Mars, where winter temperatures can plummet to minus 220 degrees Fahrenheit, we've had rovers that last for decades. The same would likely be true of Titan. The great thing about Titan is that its temperatures are relatively stable despite being so low. Because it's so far from the sun, it always stays pretty cold, never reaching the high temperatures that even the moon or the exterior of the ISS are subjected to. The surface temperature of the moon, for instance, ranges from minus 280 degrees Fahrenheit to an eye-wateringly hot 212 degrees, far hotter than the hottest recorded natural temperatures here on Earth. Our machines, and in a few cases people, obviously survive up there, but it means that any potential bases built on the moon have to withstand both incredibly low and incredibly high temperatures, which can be tricky to manage. Titan, with its consistent low temperatures by comparison, is great for a climate-controlled human outpost. It has another big benefit too, though: pressure. Though Titan's gravity is only 14% of Earth's, the pressure is just 1.5 bars. For comparison, 2 bars of pressure are equivalent to diving roughly 30 feet beneath the surface of the ocean. While this may be a little uncomfortable, it's also workable. On Titan, it means that pressurized suits and habitats would be able to easily mimic Earth's conditions. In some ways, living there would be like building a submarine that never needs to go deeper than 30 feet beneath the water. A pretty easy engineering challenge. The large amount of nitrogen in Titan's atmosphere is potentially a plus as well. 78% of the air on Earth is made of nitrogen too, with just 21% being oxygen, despite oxygen being what we most need to stay alive. Titan's atmosphere as it is roughly 95% nitrogen and 5% methane. So we still couldn't breathe it, but having a massive amount of nitrogen already there could make it far easier to create breathable air in the future. Finally, Titan's atmosphere has another helpful feature: it can block radiation. That's one of the biggest problems with trying to settle on the Moon, Mars, or even in an orbital station. In all of those places, the small or even total lack of atmosphere means that solar radiation can bombard completely uninterrupted, causing untold complications for space travelers. On Titan, though, the thicker, denser atmosphere combined with the Moon's sheer distance away from the Sun means that there should be very little radiation by comparison. Someone on Titan might even have to worry about the dangers of light even less than you do here on Earth. Though there has historically been much less focus on Titan compared to Mars and even Venus, it's clear that that's all starting to change in the 21st century. In 2004, the Cassini probe undertook flybys of the Moon and sent down a lander, Huygens. And there are finally further missions on the horizon to visit Titan again. Set to launch in 2027, Dragonfly is a robotic spacecraft that will be able to fly through Titan's atmosphere, hence the name. And this little guy is actually the final iteration of a long line of proposed missions to the Moon, with some involving high-tech hot air balloons. Dragonfly's aerial capabilities mean it will hopefully be able to travel further and faster than the Mars rovers as well. If all goes to plan, though, it'll land on Titan in 2034, and from that point will provide an untold wealth of data, sending back high-quality images of that surface and those lakes that look so much like our own. And hopefully, in time, we'll be able to determine whether Titan is hosting life or could do in the future. Life forms on Earth have, of course, thrived in even the darkest, coldest, hottest, and most hostile places. So it may be that this far-off land isn't actually so impossible after all. In many ways, it's just like Earth, but in other ways, it's a wholly alien prospect. And that's what makes it a prime target for arguably one of the most exciting space programs in modern times. What's your verdict? Is Titan the place